Hey guys, Mrs. Thompson here, and we're moving on to part 2 of stoichiometry, where we're actually going to go from grams of A to grams of B. We're going to do a 1, 2, 3 step problem. Not that hard. I just want to talk to you a little bit about how stoichiometry is like a recipe. So if I were making s'mores here, which sounds great right now, I would take 2 crackers, 1 marshmallow, and 3 squares of chocolate, and that would make 1 s'more. Now, if I wanted to figure out how many s'mores I could make, if I had, let's say, 16 cracker squares, I could do that using a little bit of stoichiometry and just saying, okay, well, for every 1 s'more, it takes 2 cracker squares, so that's going to be 8 s'mores. So a really simple real-life problem, I guess you could say. Here's another real-life problem. Here is the stoichiometry of an airbag. So airbag that you have in your car that inflates when you get into an accident. And so one of the reactions that's going on inside of the airbag is the reaction of sodium azide, NaN3. And that sodium azide will break up into sodium and nitrogen. Nitrogen is a gas, of course, and that's what inflates the airbag. And it takes a certain amount of that sodium azide to break up into the nitrogen that we need. We don't want to overinflate the bag, and we don't want to underinflate the bag. So you have to have the right stoichiometric amount. There's a couple of other things that are going on within that airbag that we're not going to talk about, but just know that stoichiometry is an important part of everyday life. Alright, so let's do an example where we're going from grams to grams. So it says, how many grams of ammonia is produced when 5.40 grams of hydrogen reacts with nitrogen and a balanced chemical equation is given? So our next step is just to figure out the given, the unknown, and the number of steps. So our given is 5.40 grams of hydrogen. Our unknown is how many grams of ammonia are we going to produce? And reacts with nitrogen is just an extra piece of information. Okay, then we need to figure out how many steps are we going to do. So remember that for gram, mole, mole, gram, half of it is for the given, which is hydrogen. Half of it is for the unknown, which is ammonia. All right, let's see. We're starting with our given in terms of gram, and our unknown we want in grams. So that means we're going to use all of it. We're going to go from gram to mole, then mole to mole, and then mole to gram. All right. So we'll start with our given, 5.40 grams of hydrogen. So right here in this chart, I need to use the molar mass. And so I have to figure out what the molar mass of hydrogen is. We have 1.01, which is the mass of 1 hydrogen. So for H2, it would be 2.02 grams of hydrogen in every 1 mole of hydrogen. So careful, remember that's always 1 with the mole when you're dealing with molar mass. Grams of hydrogen cancels, and I move on to my next step, which is going from moles of hydrogen to moles of what we're looking for, which is ammonia. So we need the mole ratio. For the mole ratio, we have moles of the given on the bottom. Given is in terms of hydrogen. In front of hydrogen, we have a 3, so this is 3 moles of hydrogen. On the top, it is moles of the unknown, and so that's 2 moles of ammonia based on the balanced equation. Moles of hydrogen cancel, and then we have one more step. So we need, let's see, from here to here, moles of B to grams of B. So again, we're going to need the molar mass, where we need the molar mass of ammonia. So we have to add up 1 nitrogen and 3 hydrogens. And that's going to be equal to 1 mole of ammonia. So nitrogen is 14.01 plus 3.03, because that's 3 hydrogens, gives me 17.04 grams. And my moles cancel. Okay, I'm going to do the math, and remember there are many ways to do this. I could take the top numbers, multiply them, put them in parentheses, and then divide them by the bottom numbers multiplied, but they're also in parentheses. Okay, or I could go times the top and then divide by the bottom for every single one. So times the top, divide, times the top, divide, times the top, divide. Okay. Anyways, when you solve this in your calculator, you should get about 30.368. Now we need to worry about significant figures. Let's count. This has 3. This one has 3. This has an unlimited amount of sig figs, and this one has 4. So 3 is the least. So we're going to chop this off right here. 1, 2, 3. So the 6 will bump up to 3, 2, 4. And my answer becomes 30.4 grams of ammonia. And so this is an example where we're going all the way across from gram to gram. And we're changing it from one substance to another by using the balanced chemical equation. All right. Second example. How many grams of silver will be formed from 12 grams of copper? And the balanced equation, again, is given. You're welcome. All right. So the given here is 12 grams of copper. The unknown is grams of silver. And if we would go from gram, mole, gram, this is a gram to gram problem. A gram of something, copper, to a gram of something else, silver. So all 3 steps. 12 grams of copper is what I'm starting with. I need the molar mass, so I look that up on the periodic table. 1 mole of copper is 63.55 grams. So 63.55 goes on the bottom. Remember, that goes with grams, and 1 is what goes with mole. That cancels out grams. And then we'll need our next step, which is the mole ratio right here, from moles of A, which is copper, to moles of B, which is silver. So mole ratio. For copper, in front of copper there is nothing, so it's 1 mole of copper. And in front of silver we have a 2, so it's 2 moles of silver. Moles cancel, and then we have another step. So I've got from moles of B to grams of B by using the molar mass, and that's the number of grams over 1 mole of that substance. So 1 mole of silver is 107.87 grams. And I just use the periodic table to find that. Then I'm going to do the math. And I get 40.7. That's because I needed 3 significant figures. I was limited by the 12.0 grams of silver. That's my answer. Hopefully stoichiometry is getting a little easier. Bring questions to class, please.